Okay, in this video we're going to discuss the implementation of the character level network using a recurrent neural network. Okay, so this one is the bar path that I'm referring to. So I encourage you to actually read this bar path. It's very in detail and very it is a very good read. Although the code provided with the author is kind of old and using some outdated frameworks, but I think it is still even better because you don't have to use the code. You can implement the code by yourself, just like what we have in our homework assignment. So basically, it is using a recurrent neural network that what we has introduced in last week to actually do a sequence-to-sequence autoregressive model. Basically, it is just about that. So, for example, if we have a HALL, then when we get the H, what we want is it output A and E, and when we have HE, then we wish it output L. So in fact, it looks like a many-to-many diagram here. It should be something like a many-to-many diagram here. But in practice, because we are also considering using a non-recurrent neural network models that only accept probably a fixed length of input data, just like consider it as a replacement for an ungrained model. So this one is also considered. Also, my code is actually written in this kind of form. Okay, so this one is the Shakespeare text. It was generated, and it can also generate more complicated things. So in fact, it has a better quality or generative quality than the previous the simple model that we just mentioned. And again, the correctness is also a structure, at least for not for factual correctness, but for structural correctness, it also get improved because this one is the text is compiled by the text source code. The text source code is a layout and language for a lot of for academic paper or scientific writings for many different fields. So it is in fact like a programming language. So in order to actually generate something that can be compiled by a LaTeX compiler, it have to have some correctness in the structure. So like we have mentioned, because our simple model or ungrained model has a very limited memory, so you cannot generate something like this one. And it can also generate something like a graph. This one is also written in a text language. So, but it requires more understanding of the structure. So if we really give a quick glance of this 2 pages of I would say the text or sentences, you probably will feel like, okay, this is something like very difficult mathematics, and chances are you are not trying to understand the material. So I would guess this kind of things is really passable for you as something that was written by a human being. So it's kind of indistinguishable for something that is written by a human. Okay, so for implementation, there are something you pretty much just replace the dictionary by a neural network. So instead of collect the data and update your table, you do the training. But there are some difference. One thing is when we do the dictionary method, we pretty much don't care about how many distinct characters are available, because there are just some Unicode. If we encounter some new character, we just, it's just a new key. There's nothing new right here. However, if we are trying to do it for say the LSTM, GRU, or other networks, what kind of expecting the input to be some fixed length vectors. So we probably we will need a finite amount of character, and that is none before we actually design the network. So one way to do that is, we simply restrict our training source to contain only like English letters, digits, symbols, some punctuals. That's one way. But if you can see the implication in my when I discussed for the assignment, one way you can do is do some quick counting and find the most popular or the most frequent character and list like 100, 200 of them, and replace any less frequent. Probably they are only contribute to like 0.1% of the whole distributions. You just replace it to be spatial words, spatial character, which we usually call it unknown. That's one way to do that. Or you can simply just ignore all of them. That's another way, but that is less common to see that. But you can do that. So there are many ways to do the things, but the most popular and common way to do that is replace less common word with something called unknown, so that we can fit them into a framework of, fit them as an input of a neural network. So other than that, it is just simply to replace the dictionary with a neural network. The benefit of using network is, even if you query it with some input that has not appears in the a training text, it will always response something. Maybe not. We are hoping it to be some reasonable response, but at least it will respond something. Okay, so that's pretty much for this part.